Well, there are times when you actually wonder, what the heck is design patterns? What are solids? What is dry? And what the heck is KISS here? I mean, what is KISS even doing here? I don't understand. I barely started out in the world of programming and I have to deal with all these things. My goodness. Now, this video series is all about design patterns. I'll be discussing about design patterns, solids, dry, KISS, their uses, and much more things. So solids are principles which we use in our programming, day-to-day programming. Dry is don't repeat yourself, a very simple thing. KISS is keep it simple, stupid. Well, you need not complicate the things out there. So this video talks why do we need all these things? Why can't we simply go out and write our programs the way we want it to be? And why we need to incorporate these kind of design patterns, solids and all these things into our program. Why is it so much necessary? What the heck is why the industry is so much fuzzy about it? Why they want us to learn, and why it's always necessary to follow these things? Now, the first and foremost rule of all these patterns and all those principles is it results into maintainable code. A maintainable code obviously makes a coder happy. Now, why it makes a coder happy, that we will learn throughout the series and throughout the session. But it results in a happy coder. Because, one of the most foremost reason for a coder being happy is that if you're asked to make a small change in an application, and all you need to do is to change one single line for that, and your application works, and you're happy because you had to do a very minimal change to achieve something. Now suppose you have to develop a new feature, probably you have to add a new feature. Now, to add a new feature, if you just extend a class, if you just write a new piece of code and that gets hitched onto the existing code without any extra effort, then that is something which would make you happy, because you don't have to tinker with the existing code in order to achieve or add a new functionality. Now that is what the industry is looking for. We don't want to test the existing piece of code again and again and again just because we had to modify it for another incoming change request or for an enhancement. We don't want to do that. That's why we want a maintainable code which is less fuzzy to maintain. Now, once we have design principles in place and all the features, all the patterns in place, the time to implement new features, as I talked about, like whenever a new change request comes or an enhancement comes or a new feature is supposed to be added, we don't have it doesn't take a lot of time. I mean, it the time required to implement that thing, that will be constant. But if the code has not been written properly, that time can definitely increase, and that is something which the software industry doesn't want. Again, one of the major disadvantages, or one of the biggest hit, is on code reusability, because you're not able to reuse the code. You might not be even able to reuse the code in the same project. Forget about using it in another project. What use is the code of if you're not even able to use it in the same project or in the other project or in subsequent projects? So code reusability takes a big hit, and I think code reusability is something which is very serious issue, because a functionality once written, once tested, it should not be rewritten or retested. So that is one of the biggest issues. One more issue is that if your code is not loosely coupled, if you have not applied principles and patterns, then your code will definitely be very tightly coupled to each other. So component wise, there won't be any single individual component in the code. Everyone will be very tightly coupled to each other. So making one small change can trigger a huge amount of cascading changes throughout the project, and testing becomes a nightmare in that situation, because you cannot test one single function, because that single function is depending on another function, and instantiation for variables and objects are done inside the function. So if the objects and variables are instantiated inside the function, then probably you cannot introduce that as a dependency from the outside world. So testing it will become virtually impossible. Code coverage, path coverage, condition coverage, all these things becomes a nightmare to cover. And eventually either you have to ship a untested software, or you have to ship it with an uncertainty that it might work or it might not work, or you may be grilled with extreme amount of change requests or issues down the path to correct all these things. if the code is written in accordance with all the principles and patterns, the modifications, as I told, the changes and the modifications will not affect the existing piece of code. You will just have to extend the current classes and you're done. And the code is always clutter free. Now there is one single thing I would like to point out here is that okay, whatever I explained till now, that is fine, that is good, everyone talks about it. But let me give you a real world example. Just look at this slide. I've prepared this slide, and this has two sections. One section is total cost of development with design pattern, and the other section is total cost of development without design patterns, which is the right side. Now you can see, like assuming the total cost for a developer or a tester per hour is $29. We assume it's $29. Now, suppose a change request comes. I'm not even talking about a new software development. I'm not even talking about a new project. I'm just talking about a very small change. So let's say a client asks you to change something in the project or probably add a very small feature into the project. Now when that change comes into the company, a project manager or an architect or some senior person will actually analyze that change. So after analyzing the change, he comes to a conclusion that probably I'm going to take 5 hours to implement that change and I'm going to need 3 developers for that. And he prepares a statement of work that, okay, I need 5 hours with 3 developers costing at $29 per hour. So that is 435 hours, $435 for that change only for development. But that is not yet it. We need to test it also. So for testing, he needs 2 testers and he needs 6 hours of effort for that. So now 6 into 2 into $29 for each and every tester. So now we have $348 for testing. So that concludes for around $783 for one single enhancement. Now that is fine. I mean, this is fine. Now, this is considering that whatever changes we do is not going to affect the current functionality, because if it does affect the current functionality in some way or the other, even if you change one single line in the current existing code, you will have to test the whole module for that, because in all likelihood you might have broken existing functionality, even though it's not apparent to you that you would have broken the existing functionality. It might not be visible directly, but yes, in all likelihood there are chances you must have done that. So you will have to test that code is also. So that is what happens when we develop a software without design patterns. Now look at the right side of the slide, the total cost of development without design patterns. Because if design patterns and principles are not implemented, if the software is not made in accordance with these patterns, then the development time will increase. And if you have to implement a new feature, new change, new modification, that will you will definitely have to tinker with the existing functionality, with the existing code. Now, all the parameters here remain the same. The cost per hour for developer for and a tester remains $29. The change project manager again analyzes that the change actually requires only 5 hours, and developers 3, cost of enhancement 435. That is fine. You modify the existing code, or you write a new functionality and attach to the existing code. Whatever way you do it, you're going to do it in 5 hours and you're going to cost us $435. That is fine. But now the number of testers required is 2. Time required to test the current functionality which has been implemented recently 6 hours. But because design principles and all those stuffs were not taken into consideration while making the software, you had to actually modify the existing code rather than extending the functionality. And because of that, you changed a lot of code which was actually working. You had to go and change the existing code, and if you had to change the existing code, then definitely that whole module and the modules which are affected because of that needs to be tested once again. Now this is what actually happens in the software industry every day. You actually have to test each and every module. Now there's another analyzation which happens. People sit and analyze which all parts of the code are actually affected just because you modified one single module. Now after analyzing that, we come to a conclusion that okay, now the time required to test the affected modules because of that change will be 20 hours. 20 hours is very little which I've actually taken. It is actually much more in the real world, but still 20 hours. Now the total cost for testing, it goes till 1500, almost $1,500. The total cost increases to $1,943. Now if we compare with the earlier version of development, which was developed in accordance with design principles and patterns, we are actually going to pay 1160, almost 1100k, $1,100 extra, just for a small change, a very minimal change or a very minimal enhancement. Now this was just for a very minimal enhancement. Think about the whole project, what disaster it could do to a whole project. So this is one of the major reasons. In fact, this is the reason which actually ignites other reasons. Code maintainability, less testing time, extendability, happy developer, happy coder, all these things are interrelated, and what you have just seen now is actually the reason for it. So I hope this clarifies the doubt, if anyone of you are having that, why are we going towards design principles and patterns? Why do we actually require them for a pet project, for a project which you're writing in your home, 2-3 lines, few hundred lines of code? That's probably not a big deal, but once you write a big software, this comes into this is the big picture which I'm showing to you. Once you write a big project, this is something which you really have to consider, otherwise it will become a nightmare, because there are many projects which are failing each and every day just because the code is unmaintainable. People are not even able to maintain the code. So that's the big picture actually. So this is the reason why you should be really comfortable with design patterns and principles and all those things, because the earlier you start with principles and patterns, the more fluent will you be with all these things, and the better coder will you be. Thank you everyone for watching this video. Hope it helps you. I'll be posting more design patterns and principles related video for your help. Hope you benefit from it. Thanks a lot. Thanks for watching.